Joule are a leading manufacturer and supplier of a full range of solar thermal systems. Whether you're looking for in or on-roof flat panel systems or the advanced vacuum tube system, Joule have a solution for you. Joule don't just supply the panels, we stock a complete range of accessories to give the complete system from one supplier. To understand how the solar controller works, we must look underneath the cover. The wiring of the controller is simple. On the left, we have the sensors, and on the right, we have the pump and power supply from your spur. On the far left, you will see S1. This should be wired to the black sensor cable which is installed in the panel on the roof. Beside, we have the S2, which should be wired to one of the two grey sensors supplied, and this should be fitted into the bottom sensor pocket in the cylinder. And finally, we have S3, which is wired to the second grey sensor, and this is fitted into the top sensor pocket on the tank. On the right hand side, we have the mains power. The pump is wired into OR1 and N, OR being the live connection and N being the neutral. The controller should be powered from a 3 amp fused spur, and this is wired into the L and N terminals. Make sure to read the wiring diagram correctly for these terminals, as on some controllers it can be a little misleading and you may end up wiring the pump into the OR2 terminal rather than the OR1 terminal. Joule supply a range of controllers to meet all system requirements. The controller most commonly used is the C4 controller, and this works with all collectors, in and on roof panels and evacuated tubes. There is only a need to have a different type of controller if you are fitting 2 hot water cylinders or tanks, or if you have collectors which face different directions and receive heat from the sun at different times of the day. All standard Joule controllers come pre-commissioned, so you just need to plug and walk away. If for some reason you need to enter the service menu, simply continue to press the top button until you see the time appear on the screen. Now press and hold this button for 3 seconds until you see the screen move again, and now you should be on a screen that reads A or. If you have held the button for too long and you are on a different screen, use the down button to move yourself back to the desired menu you were looking for. Any menu after the time menu are considered to be service menus, and any menus before are user menus. If you move back to user menus, you will need to repeat the above steps of holding the up button at the time menu to re-enter the service menus. One thing you may wish to do after you finish the installation is manually turn the pump on to check if there is air in the system. To do this, simply use the up and down buttons to find the menu HND1. This is the menu that controls the relay that switches the pump. By default, it will be set to auto. This means that the controller will decide when to turn the pump on and off for correct operation. To change this setting and all other settings, press the middle button and you will see Set flash. This indicates that the setting on this particular menu is now unlocked and can be changed. You then use the up and down buttons to select the change in the setting that you require, and then press the Set key again to confirm the change in this setting. If this is not carried out in a timely fashion, the menu will revert to lock mode and the setting will not change, and you will move to the next menu. In this case, we are changing the setting from auto to on to force the pump to run. You will see a warning triangle and a hand appear. This is there to remind you that when you are finished, the setting must revert back to auto. Another setting you may wish to change is the minimum power supplied to the pump by the controller. The controller is designed to increase and decrease the pump speed based on the temperature difference between the solar collector on the roof and the water in the bottom of the cylinder. The greater the difference, the faster the pump can run, but when the difference is minimal, then the flow rate needs to slow down to allow more time to transfer the heat throughout the coil. If you wish to only have the pump run at full speed all the time, then following the same steps as before, go to this service menu and change the default setting from 30 to 100. If you hear a low tapping sound coming from your solar system, the low pump speed is most likely the cause of this, and increasing the pump speed will remove it. Airlocks in solar systems remain the #1 technical issue. Unlike normal sealed heating systems, where the energy is put into the system through the boiler at the low point and then dissipated through the radiators at the high point where the air normally gathers, solar works in reverse. The heat is put into the system at the highest point, and the pump must drive this hot fluid and any air in it downwards against its natural direction, where it dissipates its energy into the coil in the cylinder. This means air is gathering in the hottest part of the system. A little bit of air in the coil can go to the roof, expand with the heat, and be large enough to cause an airlock. The most frustrating thing is, this air may only rise to the roof weeks or months after you install the system. Also, if you install the system in the winter, this air might not expand sufficiently in the low heat and may only expand sufficiently in the summer heat to cause an airlock. To troubleshoot an airlock is simple. If the collector temperature menu COL is reading a very high temperature above 100 degrees Celsius and the cylinder temperature menu TST is reading a low temperature 20 degrees Celsius, then the likelihood is you have an airlock. When the collector temperature rises above 140 degrees Celsius, regardless of the cylinder temperature, it will go into stagnation mode. This may happen quite legitimately if the solar has fully heated the cylinder and simply has nowhere to put the excess energy, or it may also happen if there is an airlock and the collector cannot dissipate the energy to the cylinder. Either way, a warning sign will be displayed and the solar pump will not run until the system recools below 140 degrees Celsius. Another common fault is 888.88. This indicates that a sensor has lost its ability to transmit its reading back to the controller. It may be that a wire connecting the sensor to the controller has come loose, or that the sensor itself is faulty.